Hello, fellow chemist. In this video, we're going to be taking a look at dilution problems. This is labeled an intermediate video because it assumes you have a basic understanding of the terms solute, solvent, and solution. If you need a review of that content, I'll put a link in the upper right-hand corner. So, dilution problems, basically what it is you're starting off with a certain concentration and a certain volume of a solution. That's what's over here. And then you're diluting it down to get a new volume and a new concentration. You'll notice there's three terms: starting concentration, or four terms: starting concentration, starting volume, final concentration, and final volume. You have to be given three of those four terms in the problem, and then you just rearrange the equation to solve for the one unknown term that you're not given. So I have the formula written out here as starting concentration times starting volume is equal to final concentration times final volume. That's often abbreviated as M1V1 equals M2V2. M just means concentration. The concentrations can be in any units. It could be a molarity problem. It could be a percent problem. I'm going to do these examples here as percent problems. The volumes can also be in any units. You just have to make sure that all of the volumes that you're working with are all the same, meaning you can't have your initial volume in milliliters and then solve for your final volume in liters. So you want to make sure that all the volumes that you're working with are in the same units. The same thing with the concentrations. If your starting concentration is a percent, your final concentration is going to be a percent. If your starting concentration is a molarity, then your final concentration has to be a molarity. All right, so we have two problems down here. Let's take a look at these problems and see how they work with the M1, V1, M2, V2 formula. One of the main problems that my students tend to have when doing dilution problems is they don't know how to identify what M1 is, M2 is, V1 is, and V2 is. So we'll take some time to make sure that we go through and identify each of the terms. So it says a nurse wants to prepare a 3% silver nitrate solution. So if you want to prepare something, this is what you're going to have. So this is your final concentration, or your M2. And it's from, this is what they're preparing it from. They're preparing a 3% silver nitrate solution from 24 milliliters of a 7% silver nitrate solution. So this is what you're starting with. So this is going to be your V1, and this is the percent that you're starting with, so that's going to be M1. Your M1, your initial concentration, is always going to be higher than your final concentration. So if you're picking out the number that's lower for your initial concentration, you're probably doing it wrong, because you're diluting it down. So your initial concentration will always be larger than your final concentration. Then it says, what will the final volume of the solution be? Well, that means they're asking you to find V2. All right, so if we kind of write the main equation out, M1 times V1 is equal to M2 times V2, and then fill in what we're given. We're given our M2 at 3%, and we're given our M1 at 7%, and we're given our V1 at 24 milliliters. And then our V2 is going to be what we need to solve for. All right, we have three of the four pieces of information. Now we can just rearrange the equation to solve for x. We want to get rid of this 3%, so what we do is just divide both sides by the 3%, and that will get rid of it. And that will lead us with 7 times 24 divided by 3 is equal to x, which is our V2. And then if we take 7 times 24 and divide it by 3, we end up with 56. And that will be in milliliters, because that's what our initial volume was in. So the V2, or final answer for this, is 56 milliliters. That means you started with 24 milliliters at 7%, then you had to add enough liquid into here to get this 24 milliliters up to 56 milliliters. When you did that, you diluted the concentration from 7% down to 3%. All right, so let's take a look at the second problem. Now, the second problem is I purposely worded it slightly differently so that it gives you some practice trying to solve these. So the second problem says if the initial concentration and volume of an aqueous solution, aqueous just means it has water as the solvent, is 6.8% and 32 milliliters, and the desired final concentration is 2.2%, how many milliliters of water need to be added? All right, well, it tells you says initial concentration and initial volume. So it gives us this 6.8, so that must be our initial concentration, so that's M1. And it says the initial volume is 32 milliliters, so that must be V1. Notice how I pick out all the terms before I start writing anything down in the equation. And then it says the final concentration that you want to get to is 2.2%, so that's M2. Now be very mindful of how this is written here. How many milliliters of water need to be added? It's not actually asking you for the final volume. It's asking you for how much water needs to be added. So I'm going to put down here, we're going to solve for V2, but I'm going to put a star next to it because that's not really what the problem's asking us to find. But we need to use V2 to get to our final answer. So that's why I put a little star next to it. So if we write our formula up here, M1 times V1 is equal to M2 times V2. And then we said that our initial concentration, or M1, is 6.8%. And our initial volume is 32 milliliters. And our desired final concentration is 2.2%. And we're going to be solving for V2 when we solve this equation, even though that's technically not what we want to find in the overall problem. So again, to isolate x here, we have to divide both sides by 2.2. So we'll end up with 6.8 times 32 divided by 2.2 is equal to x. So then when we solve for x, 6.8 times 32 divided by 2.2, it gives us 98.9 milliliters. And that is equal to V2. I'm going to underline that, but that's not our answer. It doesn't want to know what the final volume is. It wants to know how many milliliters do you need to add to your initial volume to get to the final volume. So in order to figure that out for milliliters added, to find that, you need to take your final volume, your V2, and subtract out your initial volume, your V1. So we would take our 98.9 milliliters and subtract out our initial volume, which was 32 milliliters. And if we do that, we will get 66.9 milliliters. And that is the volume added. It's very important in these problems to make sure that you understand what you're being asked to solve for. As you can see in the second example, you needed to use the equation, but what you were being asked to find wasn't directly one of these terms. You had to use that term to get what you were being asked to find. So always be careful and see, well, am I being asked to find final volume or how much solution needs to be added? All right, that's it for this lesson. I hope you learned something, and I'll see you in the next video.